Okay, so last section we're going to look at 7.4. There's nothing new in the section in terms of formulas or properties. It's just using the stuff we already learned Monday and Tuesday. Okay, so those people that were here yesterday, you're going to have to help us out a little bit. Or if you weren't here and you already watched the video, you might be able to help us too. All right, so first example, we want to solve that equation. Okay, solve means to do what? What does it mean to solve an equation? Yeah.
Simplify it.
And ultimately, how do you know when you're done?
You can't do anything.
So what tells you that? What about the variable? It's by itself. So solve an equation means variable on one side, number on the other side. There's your answer. Okay. All right, so the first step here is I've got two separate logarithms, one on the left, one on the right. They're each the same base, so that's good. I want to start by looking at this left-hand side. Anybody that was here yesterday remember what you can do with that 2? We have a number in front. Where can you move it to? Yeah, Tom?
As the exponent of the argument.
You could put it back as the exponent of the argument. Perfect. Okay, so that's the first thing I'm going to do. I'm going to put the number in front back as an exponent. So I have log base 5 of x squared equals log base 5 of 9. Is there anything on the left and on the right side of that equation that already matches? Yeah, the log 5. So I'll just underline it. That part in green matches that part in green. So the other thing that has to match, and we want them to match because there's an equal sign between them. So somehow you have to find a number that you could plug in here, do it out, and it would come out the same as what's right there. All right, so basically we have to figure out what number could you plug in for x, do out the arithmetic, and you'd get the number that's on the right-hand side. Josh?
3.
3. Yeah, and if you weren't sure how to get it or it comes out to a decimal, how would you solve this? What do you have to do on both sides? Take the square root. Perfect. And that's it. Okay, so on a problem like that, we try to get the numbers in front back as an exponent. Look at what's the same. You can ignore that because it already matches. Focus on what's different. X squared and 9. Somehow you have to make those match. And 3 would do it. Okay. Any questions on that one?
That's the end of the equation. That's the end of the problem.
Then we're done. X equals 3. Yep.
Is there a different process if the bases are different?
If the bases are different, that'd be a lot harder to do. I'm not gonna. I'll touch on one where the bases are different at the very end, but yeah, it is different.
Will it be on your test?
You might see something like that. I'm not sure if it would be a bonus question or just a regular one, but yeah. So we'll go over it, and that's probably one of the 2 toughest ones we're gonna do. Yeah. All right, let's look at this one. Okay, before we start it, I just want to kind of tell you a few things it's going to involve. There's going to be very few log steps. Most of this problem is going to be algebra 1. Okay, it's going to be solving a quadratic equation. What's one way that you can solve a quadratic equation? Yeah?
FOIL? No, I'm sorry,
Opposite of FOIL.
I think factor it.
Factor it, yep. And that's actually going to work in this problem. If you can't factor a quadratic, or you don't remember how, you could always use quadratic formula, which usually, a lot of people remember that one. Or if you don't want to do it that way, you could complete the square. I find most times people don't like to do it that way. But factoring is always the easiest if it works, and it will here. All right, so I'll let you know when we get to that point. Okay, this one. We've got 2 logarithms on the same side. And what do you notice about the bases? They're the same. So whenever you have 2 logarithms with the same base, separated with a plus sign, or it could be minus, this one's plus, you can combine them. Catherine, do you remember when you have a plus sign between two logs? I might have said it earlier. What you do with those two things? Exactly. So we're going to have log base 4 of x plus 3, 2 minus x. Now earlier I had asked a question, and Josh mentioned the idea of foiling, which is what you have to do here, okay, or distributive property. Now we need to do that out. So the first step is something I taught you, or I taught yesterday. To combine the two logs, you multiply. The second step, the distributing and foiling, I didn't teach you how to do that. That goes back to like algebra stuff. Okay, so Courtney, if I do my first multiplication, what's x times 2? 2x. And Tyler, what's x times negative x?
Negative x squared.
Yep, good, negative x squared. The next one is 3 times 2, which is a plus 6. And Norm, what's 3 times negative x?
Negative 3x.
Negative 3x. Okay, a couple things we can do here. One, we usually write this in order from the highest exponent to the lowest. And two, if we have some like terms, we can combine them. Okay, so the highest exponent is the squared term. Let's start with that. And Tom, if I combine my x's, what will I get?
I thought you called me Todd.
Oh, no, Tom. Yeah.
Negative. Negative 1x.
Yeah, 2x minus 3x gives me negative 1x. The plus 6, I don't have anything to combine it with. Okay. Now, looking at that equation, we have two types of equations we've studied this week. Log form, exponential form. Alexis, which form is that?
Exponential?
All right, why do you say exponential?
I don't really know.
Sure. Anyway, Cassie?
It's log form because it has log.
Yeah, it's log form because it has the word log. If it has basically that, that format where you have a base, an argument, and something on the other side, you have three things like that. I consider that negative x squared, that's just one big thing. That's log form. So what can we do with an equation that's in log form? This we learned on Monday. Dakota? Yeah, let's change it to exponential. Okay, what's my base there? 4? What's my exponent? So it has to be one of the things I circled.
The negative x squared.
1. Why is it 1?
Because logarithms always equal the exponent.
Exactly. Logarithms always equal the exponent. So the exponent is a 1, and the argument goes on the other side by itself. Okay. From this step on, it's stuff that you didn't learn in this class. It's stuff you learned back in algebra. Okay. This is now solving a quadratic equation. The only two steps in this problem that I taught you was how to get to that step and how to get to that step. Okay. The rest of it, we're just going to solve a quadratic. All right, so now, when we solve a quadratic, what do we normally have it equal to? Right now it's equal to 4 to the first power, which is 4. That's not normally what you set a quadratic equal to. 0. You're going to get it equal to 0. So I'm going to bring that to the other side. So I get 0 equals negative x squared minus x plus 6. There's one more thing we usually do if you're going to try to solve a quadratic, especially factoring.
Isn't it supposed to be 2?
2, yeah, thank you. Plus 2. We don't like that to be a negative, okay, that first term. We don't care about the sign of anything else, but especially factoring, you want that positive. So how could I make that positive? And whatever I do to that, I got to do to all of them. Yep.
You can put like the entire like sum fine.
Okay, so we could take everything that's on the right and move it to the left, and take everything that's on the left and move it to the right. Could do that.
It doesn't affect the zero.
It doesn't, yeah, the 0 will still say 0. Or what else were you
You
thinking?
can just multiply it by -1.
Yeah, or you could just multiply everything by -1, which still doesn't affect the 0 either. So if I multiply by -1, that's what I got. Negative x squared becomes positive, the negative x becomes positive, and the positive 2 becomes negative. Now we're ready to factor. Okay. Again, if you don't like factoring, but you remember quadratic formula better, do it that way. It doesn't matter how you do it. I like factoring because it's usually faster. What would be my first term in each parenthesis? Yep, both be x's. What's the signs going to be? And you figure that out by looking, you have a positive middle and a negative constant. What does that mean your signs will be down in the factoring? Anyone remember that? So yeah, there's different ways to do it, but think about two numbers that you have to multiply together. What are they going to multiply together to give you? These two numbers at the end.
2.
Not 2. Negative 2. So what kind of numbers can you multiply together to get negative 2 in general?
A negative and a positive.
A negative and a positive. And what would now be the specific numbers that you could use?
1,
1 and 2. Okay, and I'll try them in that order. It does make a difference if you do 1, 2 or 2, 1.
So I have a question. What would they be if they were both positive?
If they were both positive, when you do your factoring, positive.
Okay, then what if they were both negative?
If they were both negative, the same as what we have here. One of each. And then if they were negative positive, take these two signs and switch them. Down in the parentheses, it would be a negative negative for your
Oh,
signs. So there's four different situations you have to look at. Positive, negative, negative, positive. Those are the two where they're different. And then both positive, both negative. All right, let's check this. So x times x is x squared. X times 2 is 2x. Take away 1x. 2 take away 1 is 1x. Negative 1 times 2 is negative 2. We're good. So now we factored it. And now we just have to look at it. We're multiplying two things together and getting 0. That's the answer. What's the only way you could multiply two things together and get 0 as the result? Yeah?
Something times 0.
Yeah, at least something is 0. Maybe both, but at least one thing is 0. So either this is 0 or the other one is 0. What value of x would make the first one 0? Positive 1. What value for x would make the second one 0? So x is either one of those numbers. Those are your answers. The only thing you have to be careful about with the answers is you have to make sure when you plug them in, you're never taking the log of a negative number. Because if you do the log of a negative, it's imaginary. So I'll start with the number 1. I'm going to scroll up to the original problem, plug it in, and make sure that I never get a negative. Okay. What's 1 plus 3 if I fill in 1 for x? 4. Is that positive? Yep, we're good. What's 2 minus 1?
2 and 1.
1, is that positive? Yep, we're good. That's fine. Let's try negative 2. What's negative 2 plus 3?
1.
We're good. What's 2 minus negative 2? 4. We're good. So both of these answers work. There's 3 cases. This is one of them. They both work. Anyone have an idea what another case would be? Yep.
Only one word.
One of them works. One works, one doesn't. And how about the third case? Neither of them work. Yep. When neither of them work, there's a symbol that sometimes we use to represent no solution. Does anybody know the symbol that you see sometimes when it's no solution? That symbol means no solution. People seen that before? Anybody know where that's from? Where they get that? Is it what? I guess it could be. It depends on what country the military is in.
Well, one of them, just, I don't know, they do that for zeros, so they don't put those.
Oh, like a different way to write zeros? I think some people might also do it that way. Just like some people make a 7 like this, some people make it like that. I think that's just a difference in the handwriting. But that is actually a letter. Right there, that's a letter. It's in the Norwegian alphabet. So if you look up Norwegian alphabet, I don't know what language it's called, but it's whatever language they speak in Norway, that's one of the letters in the alphabet. All right, so that's just a symbol for no solution. Okay. Any questions on that one? All right, that one's probably, it is one of the longer ones for today. This one's pretty short. Do you have multiple logs on the same side you could combine? What do you think, Eli? You have multiple logs you could combine here?
I don't think so.
No, the word log is only written once. It's not like the last problem, it was written twice. Okay? Like this one or the one below it is what I was thinking of. Okay? We had multiple logs we needed to combine. So there's not much you can really do here. There's only one thing you could do. What's the only thing you could do to that equation? Josh?
Couldn't you do like 9, no, x to the 9th power, and then make the argument?
Oh, you mean put something back as an exponent?
Yeah.
The only time you can put something as an exponent is when the number is in front. So then it would be like that. Okay. But there's no number in front, so there's nothing you move as an exponent. There's nothing to combine. So there's only one trick we have left. Change it to exponential. That's the only thing you can do. Shannon, can you tell me my base? 3. What about my exponent? 9. And what goes on the other side? X. That's it. We know we're done because we have the letter by itself. We could do that out. That's not huge. I mean, it's not like in the billions or trillions. I think it's in the tens of thousands, but I need a calculator that does more than that. So 3 to the 9th, about 19,683. So in case they had you do that out, I'll just write it down. That's it. Any questions on that one? Okay, so that one's a little quicker. This one, not a lot really going on here either. What do you think, kind of similar to the last one, what do you think we could do with this one? Yep. Change it to log. If something's an exponential with an exponent, that is the whole reason for using a log, because it always equals the exponent. So it'll get the exponent alone. Catherine, what's my base?
2.
2? I just said logs always equal the exponent, which in this case is x. And what about my argument? 5. Only thing they could ask you to do with that is to type it in. How do I rewrite that so I can type it in on the calculator? Because it's not a base 10, and it's not a base e. I think I mentioned it earlier.
Log 5 divided by log 2.
Log 5 divided by log 2. Yep. So just to show you how that works, log 5. Make sure you close parentheses. If you don't, it won't come out right. Not that important that you close the parenthesis after the 2 because you're done. You're not typing anything else. So it's about 2.322. And this is super easy to check. Try plugging in 2.322 for x. 2 raised to the 2.322. Am I going to get exactly 5? No, because I rounded it off. I'm probably going to get like 5.0001 or 4.99, something like that. Okay, but it's extremely close. Okay. Any questions on that one? Okay, let's try this one. So it's pretty much the same as the last one. Anyone think they could tell me how to rewrite this as a log? We won't type it in on the calculator though. Josh?
Divided by 3. But, oh no.
Well, let's start with the word log. Because we're going to write it as a log. And now we got three spots we got to fill in. What goes on the left, the base, and the argument.
You can see the 3 is the base.
Yep, 3 is the base.
And x is the argument.
So logarithm always equals what kind of number? Logarithm always equals the exponent. Logs equal exponents. Okay, always. What's my exponent here? X. And 24 is my argument. And if you wanted the decimal, you could do it just like we did the last one. Okay, this problem is very, very similar. Okay, let's try this one. It's kind of similar to the last two, except in example 4, you had number to a power equals a number. Example 5, same thing. Number to a power equals a number. This one, there's a number to a power equals a number, but then there's this extra number multiplied in front kind of hanging out there. What do you think I'd have to do first here? Yeah?
Multiply the, would you divide the 8 by the 5? Or the 5 by the 8?
The 5 by the 8.
Yeah.
Yeah, you would divide each side by 8. You can't do like, if you had something like that, because of PEMDAS, you have to do that first. You can't do 8 times 2 and say 16, which I think you stopped yourself. I'm not sure if that's what you were going to say, but you stopped with the multiplication and then said, let's divide. So that's exactly what you want to do. Okay, divide each side by 8, and now you have a problem just like the last one. Number to a power equals a number. Number to a power equals a number. So if you got x by itself here, Ben, what would x equal here? So we got to do back what we did in example 5. We have to convert this to log form.
So it would be base 3 and then 5/8.
Anything else? Yeah. Log base 3 of 5/8. Any questions on that one? Okay. How about any questions on how you would put that into your calculator? If they ask you for a decimal.
Yeah, wait, how would you do that?
How would you do it? So you type in, actually, can somebody tell me? How would you put that in on your calculator?
Would you have to do like 5 divided by 8 first? Because
No, you can leave it as 5/8. You could, but you don't have to. Yep.
Do log 5/8 over log 3.
Yeah, exactly. You type it in just like that. Okay. Any questions on how to put that in on your calculator? one thing, you gotta be careful with parentheses after the top log. All right, nope, we're gonna skip that one. We're gonna do that one. All right, what's something different about this problem? It might look kind of like one we did before, but it's something Dylan had asked me about. But it's a little different. What's going on here?
Different bases.
It's different bases. All right. So normally, if these bases were the same, I would just say combine them together using multiplication with what I just circled. But you can't. So let's get rid of those. How could you rewrite this first log if you were going to type it in on a calculator? Pretend like x was a number. How would you rewrite it? It'll be a fraction when you rewrite it. Up top.
Rewrite what?
I want to rewrite that first log. And it's the same thing we did right here. I want to rewrite it, so if I was going to type it in on a calculator, I could.
So it would be log x over log 3.
And how about the second one?
Log x over log 4.
Log x over log 4. And now what I basically have is something like this. I'm going to erase this in a second, but x over 3 plus x over 4 equals 4. That's basically what I have. So if you were going to work with this equation on the right, what would it be nice if you could do that would make it easier? What would you maybe want to get rid of in this equation on the right? The fractions. If you could get rid of the fractions, that would make things a lot easier. So the way to get rid of the fractions is to multiply everything by the same number. That would cancel out your denominators. What number could you multiply by that would cancel a 3 and a 4 at the same time? 12. And I'm not going to write it as 12 because, well, you'll see in a second. I'm just going to write it as 3 times 4, 3 times 4, 3 times 4. Now the right-hand side is just a number. 4 times 3 times 4. I just type that in, see what I get. On the left, 3 in the top, 3 in the bottom. 4 in the top, 4 in the bottom. So now all I'm left with is a number times a letter, a number times a letter, and a number. Okay, I'm going to do the same idea here. What would I have to multiply each fraction by on the left to cancel out my two denominators?
3 and 4.
Careful, not 3 and 4 worked on the other problem. But we don't have a 3 and a 4 in our denominator. What do we have? Log 3, log 4. So we're going to multiply by log 3, log 4, log 3, log 4, log 3, log 4. In the first fraction, what's going to cancel out? Yep, log 3 in the bottom, log 3 in the top. What about the second fraction? Log 4. Now it's exactly like the other one I was trying to show you. It's a number times something with a variable, number times something with a variable, and the right-hand side is just a number. We're going to type all that in and write down what the number is in the next step. Okay, let's do each one of these. Let's start with log 4 times log x. Okay, I need the log of 4. 0.602. So it's 0.602 times the log of x. That's the first one. Actually, I'm just going to write it this way. Okay, the second one is log 3 times log x, and we're going to add that. So let's find out the log of 3. 0.477. Log x equals, and now type in everything that's on the right. 4 log 3 log 4. 4 log 3 log 4. Okay, 1.149. Now, on the left, what you have is basically something like this. I didn't write out all the decimals, but that's basically what you have. So what would be your next step? Yeah, combine like terms. So in this case, this would be like 0.6 plus 0.4, it would be 1x. Well, let's just add these up and see what we get. 0.602 and 0.477. 1.079 log x. Okay, so now we've combined the like terms. What can I do with this 1.079? Yep, I could make it an exponent. There's also something else I could do with it, just to get it away from the log x. Remember, just think of it as a number times a letter equals a number. How do you solve a number times a letter equals a number?
Divide.
Yeah, it's exactly the same thing. No difference at all. Just divide by that number. Okay, so let's divide by 1.079. So log of x equals, and I'm just going to do it on the calculator, divided by 1.079. 1.065. Okay, so do I have x by itself? No. Yeah, but it's very, very simple at this point. There's only one thing left you can do with that equation. What type of equation is that? Think about the two types we studied this week. Yeah, it's a log equation. What can you do with an equation that's in log form?
Change it to exponential.
Yeah, change it to exponential. There's only one thing here. The base isn't written. So what do we do for that?
It would be 10.
It would be what?
It would be 10.
Yeah, the base would be 10. So 10. And remember, logarithm always equals, what's that number going to become?
The exponent.
That's my exponent. And what's the only thing I haven't used?
X.
X. That's it. So whatever that comes out to, that's the answer. 10 to the 1.065 power. Okay, I'm not going to do that out. Okay, any questions on that one? It's a little bit tricky, but if you get confused by those two things I just circled, pretend like it's just a letter, like I did right there. And you do exactly the same steps. The only extra step is at the very end. You have to change log to exponential form. That's it. Any questions on that? Okay, so those are all the different types of problems that you could have. I'm going to give you one more. This is like example 2. Okay, that's the case where sometimes you get two answers and they both work. One works, one doesn't. or they both don't work. Okay, so take a few minutes, try that, and see if you can figure out what the answers are, and then figure out, do they work? And then we'll finish that up, and that'll be the last one. All right, so how about, let's see, Cassidy, what's the first thing that you think we should do here?
Combine them.
Yeah.
Okay, so it's log 4, or base 4.
Base 4?
Yeah. Then times x, like x is going to c times x minus 3.
Yeah, it's log base 4 of, and now you're going to multiply those together. Why do you multiply? That's just the rule. Whenever they're added, to combine, you multiply. So let's multiply it in the same step. What do you get if you multiply that out?
X squared minus 3x.
Good. X squared minus 3x. Okay, Courtney, what type of equation is that?
Log.
It's log. So at this point, what could we do with it? Nothing left to combine. There's no numbers in front. We could move as exponents. There's only one thing left.
Or move the 1.
We are going to move that. We're going to move some stuff around, but we're not just going to move the 1. We're going to change that equation.
Exponential.
Yeah, we're going to change it to exponential, so a whole bunch of stuff is going to move. What would be my base?
4.
Yep, base is 4. How about Tyler? What would my exponent be? 1? Good. And on the other side by itself, Dakota?
X squared minus 2x.
Good. X squared minus 3x. Okay, from here on, we're done with logs. Now it's just solving a quadratic. Shannon, what do we always get it equal to when we solve a quadratic? 0. So I think the easiest thing would be to just subtract 4 to the first power, put it on the other side, and do 4 to the first power at the same time. So Alex, what is 4 to the first power? 4. So I'm going to minus 4 from each side, and I'm just going to write it a little lower. We get 0 equals x squared minus 3x minus 4. Let's factor it. Josh, my first two terms in each parenthesis.
It would be x plus 1, x minus 7.
I like the idea of the x and the x. That's good. And I like the plus and the minus. But the two numbers that you give me have to multiply to give you 4.
Wow. So it'd be 1 and 4.
Yep, 1 and 4. 2 and 2 is also an option, but I'll tell you 2 and 2 doesn't work. It is the 1 and the 4. And do you want to do 1 and 4 or 4 and 1?
Would be 1 and 4.
Yes. We want it to be 1 and 4, and we want the bigger number to have the negative sign, so it comes out negative 3. Let's check. X squared minus 4x plus 1x minus 4 plus 1 is minus 3. Perfect. Okay, so Heather, what would be my answer to the first factor?
1, wait,
Negative
negative 1.
1. Second factor? 4. Is there anything else I have to check before I just say I'm done? Make sure when you plug them back into the original, you never get a negative. Let's check 4. Okay. If you plug 4 in right here, would it be a positive or a negative? How about Eli?
Positive.
Yeah. What if you plug in 4 here?
Positive.
Positive. So that one's good. Okay, 4 is okay. So 4 works. Let's try negative 1. Alexis, if you plug in negative 1 here,
Wait, I thought it was 1.
is it?
no.
No, yeah, it is negative 1. Would this be positive or negative if you plug in negative 1?
Negative.
Negative. And now here, this would also be negative, but it doesn't even matter. So what does that mean about the negative 1?
Negative 1 doesn't work.
It doesn't work. Okay, so the only answer you should put for that problem is 4. Okay, so that's the case. We did the case where they both work. We did the case where one of them works. The only case I didn't show you is where they both don't work. But you check them, and they both don't work. And remember, you might see that symbol. Great. So any questions on that one? All right. So you've got, let's see, about 20 minutes. Yes, about 20 minutes left. Okay, so I'll give you the time that you have left. You can start the homework. Okay, it's on page 490, and it's 9 questions. 1 through 3 all. 5, 6, 9. 17 to 21 odd. Okay. Just as a reminder, I will be after school today for extra help because we have our last test for the term tomorrow. Okay, so by tomorrow, anything you have to finish up, especially if you're being dismissed, just make sure you get that done before Friday. Okay, because Friday's pretty much it. Okay, next week we have the final. Okay, finals on Thursday. And if you need any time to finish, you'll have a little bit of time on Friday. And I'll also collect your books on Thursday.